Welcome back. We're continuing to use a table to graph the underlying functions. So let's look at another example. Let's say we have the side of a square, and this is given in feet, is the domain of a function. And the range of the function is the area of the square, and that's given in feet squared. Feet squared. Okay, so this is indeed a function. Area is a function of the side of a square, and we're going to define the domain as 0, 2, 4, 6, and 8. And the area is respectively 0, 4, 16, 36, and 64. Okay, so we have these values and we want to see what the graph of this function looks like. So let's go ahead and do this. One thing we can actually go ahead and assume, or not assume, but actually make a statement about, is that neither of these are going to be negative. We can't have a negative length, just like we can't have a negative amount of area. So all the points of this entire function are going to lie in the first quadrant. So we can just isolate the first quadrant. And actually, it's easier to scale when you learn how to do that. So, and we'll just look at a few more of these examples just so we can get a better handle on doing that. It makes things, especially graphing functions, much, much simpler. 1, 2, 3, 4, 5, 6, 7, 8. Let's go ahead and scale this by 10, 20, 30, 40, 50, 60, 70, 80, and our x values are 0 to 8, so let's go ahead and scale these by 2, 2, 4, 6, 8, and 10. I think we have 12 right here. Okay, so let's go ahead and pick out a few points, and all we simply do is have to connect the dots. So we have the point 0, 0. So, and that makes sense. Whenever the side of a square is 0, our area is 0. It's kind of weird to think about, but we can have 0, 0. We can't have a negative number. Our next point is 2, 4. So 2 and 4 should be somewhere right here. 4 and 16. 6 and 36. And 8 and 64. Okay, so all we have left to do is connect these dots. Oh, excuse me. This dot goes right here. Just connect the dots with the line as best we can. This is actually sloping upward. You'll see something looking like this actually quite often later on in this section, and you'll be dealing with it quite often in calculus as well. So this is sloping up, but this is the function, the visual representation of these values for the underlying function, and that's actually what we're trying to work on here. We're trying to get a better handle on what we're using to graph these functions. Okay, let's look at another one. Let's say we're dealing with, our domain is dealt with in hours, and our range is dealt with in earnings. So this could be either from working at a job or earnings you're paying for a mechanic or something like that. But we're paying something by hour, being paid by the hour. So we have the domain 0, 10, 20, and 30. And our earnings, respectively, are 0, 80, 160, and 240. I believe we looked at an example similar to this earlier. So let's look what the graph looks like. Now, this is, in fact, dealing with an actual numerical quantity, hours and earnings. We know neither of them can be negative, so we're just going to use the first quadrant. So our first quadrant, we're going to have the f of x axis, the x-axis, and our earnings for our f of x values are going up to 240, so we need to scale properly 1, 2, 3, 4, 5, 6. So let's go ahead and use 50s. 100, 150, 200, 250, and 300. And then our hours are going by factors of 10. So let's go ahead and use factors of 10 for hours. 20, 30, 40, 50. The more of these we do, the better handle we'll have on actually scaling our graph when we're graphing a function. For now, let's go ahead and plot a few points. We can see that if we work 0 amount of hours, well, obviously we're not going to make anything. So we're going to start at the origin. Work 10 hours, we get paid $80. 20 hours, we get paid $160. After 30 hours, we're at $240. And we definitely have a linear equation here. So we simply just connect these dots as best as we can. Our scale's a little off, but the line goes through all of these points here. And we're going to assume that you can just keep on working and you'll be paid the same amount of hours, or excuse me, the same amount of earnings per hour. So we can extend that infinitely. Okay, let's go ahead and look at one more. Let's squeeze one in here. Let's say we're given the table. Our domain is called x. Our range is called f of x, which is a function of x. And our domain contains the quantities 0, 1, 2, 3, 4, and well, let's make it 5. And our function evaluated each of these points, or each of these values, is respectively as 100 for 0, 120 for 1, 140, 160, 180, and 200. Okay, so we're not actually told anything about what's going on here, but it looks as if we're being charged a $100 fee for something, or we're charging $100 for something, and then maybe $20 per hour, or something to that effect. So, but since we're not told anything, we're not told it's exactly hours like we are over here, so we can't just include quadrant 1. We're going to have to graph the whole thing, and that's not saying that it's going to be just in quadrant 1, but we have to include the possibilities of being negative, even though it seems obviously like we're working for something per hour with a flat rate of something. Okay, so let's go ahead and label our hours. 1, 2, 3, 4, 5. Not that it's hours, but I'm just assuming it's hours. And then down here we have up to 200, so let's go ahead and scale this by 40s. 800, 80, 120, 140, or excuse me, 160, 200, and 240. Okay, this is just a rough sketch. So we have 0, we're at 100 at 0. Let's get a different color here. At 0, we're at 100. At 1, we're at 120. And this is going to result in a linear equation. 140, and then 200. 200 is up here. Okay, something to that effect. So let's go ahead and connect these lines, or connect these dots with a line. And we're not told anything about what this is actually describing, so we're going to go ahead and assume that this is continuous and that it goes infinitely in one direction, and that it goes infinitely in both directions, in the positive and negative. Because we're not told that it's a real, it's an actual quantity, so we have to assume that the domain can be negative as well, and that it's continuous in both directions. So be careful with the information that we're given, and more importantly, the information that we're not given. We can't just assume, even though we've done examples like this, we can't assume that we're talking about an actual quantity. So we have to assume that it's continuous in both directions. So we're graphing functions here, and we're getting an idea of how useful a table of values is when we're trying to graph a function. We want to get a visual representation of what a function looks like, so we can pick off things like its trend, its slope, and such things like that. We'll do a lot more with these in the near future. I'll see you soon.